Hi everybody, thanks for being here. It's John Pushkar. Today it's episode 3 of my 4-part series, items 11 through 15, from my 20 real-life fired equipment and mechanical systems hazards episode series. So sit back, relax, remember, take good notes, email me if you have any questions. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. If you're doing anything that has to do with starting up steam lines, there's an element of danger here. You have to understand that any steam that passes an open isolation valve in a cold system, well, it immediately turns to water. And that piping system better be able to get rid of the water that's generated very quickly and effectively. If not, it'll tend to get picked up and accelerated at the velocity of steam flow in the pipe. And you don't want that to happen. Steam could flow in pipes at 60 miles an hour and above. Imagine picking up an 8-pound, 1-gallon slug of water and accelerating it at 60 miles an hour, and then asking that to turn a corner or to negotiate its way through a valve or some type of pressure control device. The results are not very pretty. You see, steam systems have to be designed in a way that the steam traps are large enough for startup, or you do supervised startups where people are draining the system at key strategic points. Well, if you look up and you see pipes moving around and swaying, that's a danger sign. If you actually hear thumping or pounding like someone's hammering the steam line, that's called water hammer, and that's another very obvious danger sign. And it's not just failed traps. If you have hanger failures and the pipe is sloped in the wrong direction, or if you have carryover from a boiler where I'm just loading water into the boiler steam header, you can also get to a dangerous water hammer condition. So again, make sure you go very slow. If you start to experience water hammer, you need to back off, maybe get some folks at strategic drain locations, but never accept chronic water hammer and swaying of pipes. I have been to facilities where there have been catastrophic failures of piping systems. At one such facility, a 6-inch elbow blew off of a steam line that unfortunately was insulated with asbestos insulation. It snowed asbestos in the facility, and the facility was closed for weeks while the asbestos was remediated. And by the way, for the benefit of whoever it is that's manipulating steam valves to put steam into a system, be aware that these kinds of valves, especially in high-pressure systems, they have packings around the stem. If those packings let loose, you could be in for a world of hurt. You could also be exposed to a gasket blowing out at a flange connection or at the bonnet of a valve. You should always be wearing PPE when manipulating steam valves, so that means at least gloves, leather protection for your arms if you have it, maybe face shields, and maybe some clothing that can protect you from a sudden heat release. Folks, little pressure vessel leaks can be a sign of bigger catastrophic things. What I'm showing you here is an incident that occurred outside of St. Louis, Missouri. I was an expert for the attorneys involved here for the plaintiffs' families. There happened to be 4 people that tragically died this day when that pressure vessel that you see in the middle of the photo launched through the roof of the facility where it was part of a boiler system. It came down 520 feet away through a roof and killed 3 more people. This thing was an unfired pressure vessel. It was a condensate receiver. It was a pressurized condensate receiver, so it stored a lot of potential energy. It was about 20 feet long, 3 feet in diameter, and a couple of thousand pounds. This pressure vessel, well, it had been repaired previously, and there was a small leak that was occurring again. If you look at the picture in the top left of the page, You can see it was a relatively small leak. It wasn't like there was water or steam blowing out of it with great force. It had been noticed by the operating staff, and they had scheduled a repair for a Monday. They decided to run one more shift on a Saturday, and that's when the tragic event occurred. You can see to the left of my picture, you can see that a substantial part of the roof is gone at this box manufacturing facility. That's where the pressure vessel started its journey. It came through the roof at 125 miles an hour, and it ended up, again, 520 feet away at this linen facility, where a husband and wife were starting their first day of work. They were sitting in the HR department when the thing came through the roof and tragically took their lives. So what are some of the lessons here? Well, pressure vessels, by their very nature, they store lots of energy, and they can be very dangerous. You need to identify and document all of the pressure vessels at your facility. And pressure vessels are associated with more things than just the steam system. Compressed air receivers, for example, can be pressure vessels. Make sure that you have a mechanical integrity program for all of your pressure vessels and your pressure piping. OSHA has a process safety management requirement for facilities that manufacture or store on site certain threshold levels of chemicals. But whether or not you are officially a PSM facility, their program has a lot of great information that can really help you with an MI program, even if you just have a few pressure vessels. I encourage you to look up OSHA's program and benefit from some of the information and practices identified there. And remember to be careful about people doing repairs on piping systems and pressure vessels. Lots of people say they're certified welders, but you should know there's probably 20 different certifications, if not more, that welders can say that they have. There are very special requirements for people welding and servicing pressure vessels and pressure piping. And if you want to know more, check out www.nationalboard.org. That's the National Board of Boiler and Pressure Vessel Inspectors. If you contact them, they can tell you more about who is and who isn't qualified to weld on pressure vessels. You should be looking for someone who is an ASME code shop. If you want to know more about this incident, there's a great video and report at www.csb.gov. This is the U.S. Chemical Safety Board website. There's a lot of great free training materials there that I've found very helpful throughout the years. You should also know that safety relief valves need your attention. Safety relief valves fail by leaking, folks install them improperly, and they also need to be inspected and tested regularly so that you're in compliance with local jurisdictional rules. You don't need to have a lot of training or experience with safety relief valves to identify a leak. If you walk by, maybe you're on the roof, maybe they're inside a facility, and you see a little wisp of steam coming out the top, or you notice water constantly draining or dripping out of them, it means that they're weeping. This is a failure at the seat of the valve where there's small amounts of steam that are getting past that connection. When that happens, minerals in the water start to collect at that seat connection. They can compromise the ability of that safety relief valve to open and function properly. So if you've got leaking safety relief valves, you've got to get that addressed sooner rather than later. And what about some of the installation mistakes that are relatively common? Well, I can't make you an expert on safety relief valve installation here, but let me just show you a couple of them. One is that there should be no weight carried on the valve body itself from the discharge piping. That's why these are usually installed with a drip pan elbow, where there's a relatively larger discharge pipe that sits over the relief valve discharge assembly. They're not supposed to be in contact. That discharge pipe should be firmly clamped and supported so it's not actually resting on that drip pan assembly. Another thing that should be relatively easy for you to see is you should never be restricting or reducing the size in or the size out of piping systems that are connected to safety relief valves. And oh yeah, I'm not just talking about relatively large boiler systems or gas-fired equipment. I'm also talking about hot water heaters. They could even be electric hot water heaters. There have been tremendous catastrophes from the energy that's stored in hot water heaters when relief valves have failed. You need look no further than the terrible tragedy that occurred in 1982 at the Star Spencer School in Spencer, Oklahoma, where 5 students and a teacher were killed when a safety relief valve didn't function properly. You know you can store as much energy as is contained in 10 sticks of dynamite in a 100-gallon hot water heater? So again, don't overlook the small stuff. You might want to think about this even in your own home. Most folks ignore safety relief valves on hot water heaters. I'm here to tell you, you should be reading the information on the tag. You should be replacing them on a periodic basis. They're relatively inexpensive, and it's simple to do. Make sure you isolate the system first. Make sure that it's cooled down so you don't have any issues with burning yourself when you remove it. There's also instructions from manufacturers which identify how to do this. And if you operate any kind of commercial or industrial facility and you have steam boilers with safety relief valves, or you have safety relief valves somewhere downstream in the system, maybe after pressure reducing stations, there is a requirement in most jurisdictions that these be tested. And there are a number of different tests which need to be performed. This is where you need to get someone experienced and qualified. And I will tell you that when it comes to boilers, most people have a fresh set of safety relief valves that have been tested and calibrated at a shop, and they just rotate them into service periodically. If you have no testing and inspection program of safety relief valves, you need to contact your jurisdictional inspector or the folks that are providing you with boiler insurance, and it's something that you need to address right away. You should know that steam leaks can be deadly. You can't accept little steam leaks. Remember that little pressure vessel leak? You saw what happened there. Likewise, the little leak from a steam valve packing, I talked about that. Part of the problem is that you never know when a little steam leak is going to turn into a big steam leak. You see, if you're in a cloud of steam and it's over 120 degrees and 12% moisture, one breath of that steam could cause severe damage to the inside of your lungs. And I'm showing you there in the little table how quickly even a small 1/4-inch leak could fill up a room. So just as there are confined spaces and special rules for confined space work, you need to think about when you're sending people into situations where there could be a massive steam leak and you may not have a way to rescue them. So for example, working in tunnels where there are steam lines, working in manholes where there are steam lines. These can be very hazardous situations, even if they're not officially described as confined spaces. I have an episode about a horrible tragedy that occurred at a facility in Kansas that was the largest power plant in Kansas, when there was some relief valve piping that wasn't installed correctly, and 2 gentlemen went up in an elevator. These are very large facilities. The elevator doors open and they were tragically overcome with steam. So if you get a chance, check out this episode. There's a lot more information here about steam leaks and steam hazards. So hopefully after today, you'll understand that the short studded fastener on the right is a hazard. You see, you need to have 1.5 to 2 threads protruding through a nut to get the design clamping force intended for that bolted assembly. But I want to make you aware here of a more general case. I want to make you aware of the fact that bolts and nuts, well, they have different strengths. They're made from different steel chemical compositions, which change their characteristics, and they're made in different thicknesses and thread patterns. If you look on the lower left, you'll see what's called an unmarked fastener. Those are the weakest. They're also called slick heads. Then you'll notice a number of different radial lines on the heads of these other bolts. And you'll see on the table to the right of my photo, there are different strengths given for those fasteners. I'm trying to encourage you here to have bolting procedures, especially for some of the more critical or high-pressure services at your facility. Your maintenance staff and maybe the supply room where people get fasteners, well, they should understand that fasteners have different strengths and characteristics. And these bolting procedures, well, they should identify just what fasteners should be used in what applications, and then they should go further and talk about tightening patterns. They should talk about the types of gaskets to be used. They should talk about using matching nuts that have the same strength characteristics. They should talk about what torque these fasteners should be tightened to. Does it make sense to you that we're very, very careful and have welding certifications, but anybody can bolt up any connection? Doesn't make sense to me. And you need look no further than the terrible tragedy that occurred in October of 1990 aboard the U.S. naval ship Iwo Jima. The ship had pulled into port to have some steam valves rebuilt that isolated one of its boiler systems. Unfortunately, a terrible mistake was made, and the wrong fasteners were used. In fact, they were plated brass nuts that critical high-pressure steam valves were reassembled with. When the ship's boilers were fired up and the ship started underway, these valves rapidly disassembled, releasing lots of steam into areas of the ship where sailors were quickly overcome. Tragically, 10 of them perished in this incident. And again, because there was a fastener mistake made. Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services Online School, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being a legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours.